Have you ever just stopped and wondered, how does something ridiculously complex, like a brain or a whole ecosystem, come from, well, from a bunch of really simple parts? It's this age-old puzzle, right? And it feels like we're finally starting to get some real answers. So let's just get right to the heart of it. This is the big mystery we're going to unravel today. How can a bunch of simple individuals, and I mean, no leader, no grand blueprint, somehow create something that looks a lot like collective genius?
All right, to kick things off, let's talk about the army ant. Now, biologist Nigel Franks said it best. A single army ant? Well, it's not exactly the sharpest tool in the shed. Seriously, if you put 100 of them on a table, they'll literally just walk in a circle until they drop dead from exhaustion. Not a lot of brain power there.
And this is where it gets crazy. You take 500,000 of those same ants and put them together, and suddenly something incredible happens. They become what scientists actually call a superorganism. It's like they merge into a single intelligent being that can do things that are just mind-blowing. So there it is, the ant colony paradox. How do you go from a bunch of, let's be honest, pretty clueless individuals to this brilliant, coordinated group? Let's take a closer look at what's actually going on inside that colony. So you've got this colony, 500,000 strong, and get this. There's no boss, the queen isn't giving out orders, there's no ant general calling the shots. It's totally decentralized. And yet this leaderless group solves incredibly complex problems. Finding food, building literal bridges out of their own bodies. It's amazing. And like Nigel Frank said, the more we look, the weirder and more wonderful it gets. Okay, so this isn't just some weird fact about ants. This pattern is everywhere. It's a fundamental principle of how things work. Really, it's a whole new way of looking at science, and it has its own set of rules. Let's check out another example to see what I mean.
And you don't even have to leave your own skin to find one. I mean, just think about your immune system. It works in almost the exact same way as that ant colony.
What's wild here is the scale. Just imagine you have about 1 trillion tiny soldiers, these lymphocytes, patrolling your body right now. And again, no one's in charge. Each individual cell is just following a few simple rules. See a bad guy, raise the alarm, and make more of yourself. That's basically it. And from that simple playbook, you get this incredibly smart, adaptive defense system that can learn and remember. So what do the ants and your immune cells have in common? They're both what scientists call a complex system. And the recipe is always the same. You need 2 key things: a bunch of components with no central control, and each of those components following some simple rules. You mix those 2 things together, and poof, you get this complex, intelligent, adaptive behavior that seems to come out of nowhere. To really get our heads around this, we have to change the way we think about science. I mean, we have to move on from a way of thinking that's been the bedrock of science for hundreds of years. So the old school approach, going all the way back to Descartes and Newton, is called reductionism. And the idea makes a lot of sense, right? If you want to know how a clock works, you take it apart, you look at each little gear and spring, and you figure that if you understand all the pieces, you'll understand the whole clock. The problem is, for these complex systems, that just doesn't work. It completely falls apart. Because it turns out the whole is truly more than the sum of its parts. You could study one ant under a microscope for 1,000 years, and you'd never understand the colony. It's like trying to understand a dream by studying a single brain cell. You're missing the big picture. And this right here nails the difference. Reductionism is all about the individual parts in isolation. Complexity science, on the other hand, says, forget the parts for a second, look at the interactions between them. The magic isn't in the ant itself, it's in the connections between the ants. It's not the cell, it's how the cells talk to each other. That's where the intelligence comes from. Okay, so if you can't take these things apart to study them, then what do? Well, this is where it gets really cool. Scientists can now use computers to build these complex worlds from scratch and just watch what happens. The tool they use is often called a cellular automaton. The easiest way to think about it is like a giant grid of pixels, kind of like a checkerboard. Each little square or cell can be either on or off, black or white. And the only thing a cell does is look at its immediate neighbors and follow a few super simple rules to decide if it should turn on or off in the next step. Probably the most famous one is called Conway's Game of Life. And its rules are so simple. You ready? Here they are. A dead cell comes to life if it has exactly 3 living neighbors. A living cell stays alive if it has 2 or 3 neighbors, and a living cell dies if it gets too lonely with less than 2 neighbors. That's the entire instruction manual. But then you hit play, and what happens is just astonishing. From those 3 tiny rules, all this behavior just emerges. You get these patterns that move, that grow, that build things, and that interact with each other in ways you could never, ever predict. It looks alive. You get all this amazing complexity from almost nothing. So we've seen it with ants, with cells, and even in a computer game. Simple, local rules can create these huge, complex patterns. And this is more than just a neat party trick. It's a whole new way of seeing the world around us. So, why should you care about any of this? Why does this science of connection actually matter? Well, because these same exact principles are at play all around us every single day, shaping our reality in ways we barely even notice. I mean, think about it. If you want to understand how a disease spreads, how an entire ecosystem stays in balance, or even how your own brain creates thoughts, you need to understand complexity. It's the key to understanding the stock market, why traffic jams happen, and how the internet even functions. All of these are complex systems, built from the bottom up. So here's a little challenge for you. The next time you see a flock of birds swoop and turn all at once, or you see a meme just explode across the internet, take a second and ask yourself, what are the simple hidden rules that are making that happen? What are the invisible connections that are building the complex world right in front of my eyes?